Hello everyone. This is going to be section 6.1. Since I moved the exam to next Tuesday, November 3, right? So well, the exam is still going to be over the same sections that I have said before. So since I've moved this exam to November 3, so this Thursday, which is today, I still need to cover something. So that means I will be moving on. So I'll be covering the section 6.1, uh, which is going to be part of exam 4. Okay. So that means I've also extended the homework, the last homework, which was 5.2, 5.3. So in case if you guys haven't done this yet, here is a chance to do it again. Or if you missed it, or if you guys didn't do everything correct, you can still go back and do it again. Since I extended the exam, so yeah, I also decided to extend this to Saturday, which is a normal usual date that I normally assign most of the homework, right? So, or well, yeah, normally I make the due date of most of the homework Saturday. So yeah, 5.2, 5.3 is going to be due this Saturday, October 3, 31. Okay. Okay, let's move on then. So I said this is going to be section 6.1. So section 6.1 is basically, well, here technically I'm not going to cover anything new compared to what you guys learned in algebra. So I will just review the things that you guys did in algebra. So here, this section is basically its inverse function. Okay, so the inverse function. And the inverse function, the first thing we need to know here is one-to-one. One-to-one function. So what is one-to-one function? So one-to-one function is, let's say, if we have a function f of x is equals to capital Y, f of capital X is equals to capital Y. So here x and, okay, so here x, you can say that the x is input and the Y is output, right? So let's say this thing in a graph. So let's say the input is going to be in this and output is going to be here. So let's say this is, as I said, this is input. So this is X, this is output, this is Y. So when you give some input, let's say A, the output you will get, let's say is B. When you input C, the output you'll get is, let's say, D. And let's say from here to here, since we said that this function is f function, so from this way to this way, if you give x as input, the y is output. So this direction, we said this is f. Okay, so if this has, if the single input has single output like this, now this kind of function, we said this is one-to-one. Okay, now what about, let's say, what about A, B, C, D. Okay, now let's say that when input is A, output is C. When input is B, output is also C. Okay, and when input is C, sorry, when input is let's say E, output is D. So what we can see here is this two input has same output. So that means if we have two different input with a same output like this, where again this is f function. So in this kind of case, we said this is not one-to-one. Okay, so it is not one-to-one. So that means we can even say we can even see this in a graph. So let's say if we have a graph something like this, and let's figure out if this graph is one-to-one graph or not, one-to-one function or not. So and In this case, we are going to use horizontal line test. So which means we can make a horizontal line that goes through this graph. So if you find, or you can make a few horizontal lines. So if you can find a horizontal line that crosses this graph more than once, or more than one time, then we can say this is not one-to-one. And we can see that this one crosses here, 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 so which is more than once. So this is not one-to-one. So that means technically, let's say, I said that here, I said that if two different input has a same output, then we say that this is not one-to-one, right? So we exactly see the same thing. So here, here, here. So these are all different input, right? This is x-axis, this is our y-axis. So all of these input has same output because y value are always going to be here, right? So that's why we use horizontal line test. Okay. Now, now let's see the inverse, which is actually which is about this. This topic is about, or this section is about this topic, right? So the inverse function. So inverse function. Let's say again. Let's say this in a graph. I've said this is x. This is y. This is input. This is output. So from here to here, we say that it's f. We have different input. Different output. Okay, so from here to here, we said that it's f. Now, the way we say the inverse is, now if we go from this output to this input, so let's say from here to here, this direction, then this direction, we say from input to output, it's f. Now from output direction to input direction, we say this is f inverse. So f inverse function, we can even write it. So for f, we say f of capital X is equals to y, right? Now from here to here, we say f inverse. Now from here to here, the output of the f function now is going to be the input of f inverse. Since we're going from this direction to this direction, so here this is going to be input and this is going to be output. So yeah, this is how we write. Okay. So so let's say if f of 5 is equals to 9, then what is f inverse of 9? All right, so like I said before, since this is input, this is output, for f function now, for the inverse, now this is going to be input. So if this is 9 is input, the output is 5, right? Simple logic. Now, what about if, let me just do it on a different page. What about if a function is given f of x is equals to x to the power 3 plus 5. Okay, so now the function is given. Now let's find the inverse of this function. Okay, so now to find the inverse of a function, first thing we need to see if the given function is one-to-one or not. So you can only find the inverse. So we can say the inverse exists if the function is 1-to-1. So if this function is 1-to-1, then only we can find the inverse of this function. Okay, so as we can see that there is x to the power 3. So the SIP of this x to the power 3 is always like this, the SIP. Okay. So now we can also see, we can also say that from this graph, if we do a horizontal line test, well, all of these horizontal lines are just going to cross this graph just once. So this horizontal line is crossing this graph just here. This horizontal line is crossing this graph here, here. So basically the single horizontal line is just crossing this graph just one time, right? So that means we can say that, okay, this is one-to-one functions. Now we can find the inverse. So now the way we find the inverse is, okay, so now f of x is equals to x to the power 3 plus 5 is given. So now to find the inverse, okay, first thing we gotta do is change this f of x to y. Everything else is gonna stay the same. After this, interchange x and y, so which means change this y to x and this x to y. Now, now solve for y in terms of x. Now, basically isolate y, which means just move this 5 to other side, which will be -5, y to the power 3, or let me just write it like this. Now, basically, we're just trying to make just y on one side, okay, and everything else on the other side. So we still have this power 3 on here on the top. So let's just take the cube root on both sides. Take cube root on both sides. Then this two are gone. So we just have y on left hand side. So y is equals to cube root of x minus 5. Okay, so that means we are gonna get, yeah, so after this, okay, this is the inverse. So now after this, since the way we write the inverse is this way, so here f inverse of x is equals to x minus y. Okay, so yeah, this is the way we find the inverse if function is given. Okay, so now let's look at the derivative of inverse function. So the derivative of the inverse function is basically the same thing as the derivative of a regular function. So let's say if you are trying to find the derivative of a function at a, then we say that it is okay, so x plus a, right, minus f of x over a, right? So basically the idea here would be these, wait, I think I did this wrong. So let me go back and explain this. Just a moment. Okay, so the derivative, if you go back to section 2.1, so the derivative there, we said that the derivative of a regular function at a point A is basically x, limit of x that goes to A of f of x minus f of A over x minus a, right? So here for the inverse, it's the same thing. So now instead of f, we have f inverse, and now we're finding the derivative of this. So the way you write the derivative is like this in the top. So it's the same thing, okay? So f inverse of x minus f inverse of a over x minus a, where x goes to, the limit of x goes to a. Okay, so that's just that. This is just the definition, right? The definition of finding um, the derivative of inverse functions. Okay, now here that's all I want to talk about from this section. So we will be using the idea of this section later on different chapters. Okay, but this is all I want to talk about from this section. So the next one I will be talking about is exponential function, and after that I will be talking about logarithmic function. Okay, so I will be using the concept of this inverse uh, this inverse functions later on different section. Okay, all right, thank you so much.